This is my friend Shaun. He's a maker. This is me, David. So focused, huh? And this is Tombalek, a traditional craft workshop where you make things, epic things. I spent a morning at the workshop with my friends forging a knife, from this to this. It was an incredible feeling being able to forge my own knife through an intricate and intense process that involved heating steel to higher temperatures, hammering it into shape, and carefully grinding and sharpening the blade. You can learn more about my experience in our podcast episode we did after our session. Now, one of our responsibilities as educators is to connect what students are learning at school to the real world, showing them that the knowledge and skills they are learning are actually used by professionals out in the real world. In this video series, we'll take a look at real-world projects like the forging of tools, alongside project-based learning (PBL) design elements, and student content standards to reveal a powerful connection that is sometimes hidden between academic learning and practical application. This examination can help us as educators to design learning experiences that are more authentic. I'll be identifying the following science content standards through this knife-making experience to show how standards and success skills can be taught authentically through a project, as well as identifying PBL design elements that make this experience so authentic and project-based. How might we forge a metal tool? This is the challenging question that we embarked on. It's open-ended, it's student-friendly, and is cognitively demanding that connects to a real-world context. This question triggers a sustained process of inquiry, a deep and iterative process of investigation that goes beyond simple information gathering. This question leads to inquiry questions like, what tools should we create? Which steel should we use? What does it mean to forge? And how do we forge steel? How do we shape and sharpen our steel? All questions leading to seeking answers through various resources and experiences, and then deepening their inquiry based on their findings. This process is essential in any learning experience because it encourages students to be curious, use critical thinking skills, and help build a lasting understanding of the subject matter. After identifying the tool that students want to create, they would ask, which steel should we use? The investigation to answer these questions involves the following standards. Here, students would conduct investigations to identify the characteristics of different steel, such as hardness, strength, and durability. Students can also test different steel to see how they can hold up under stress, heat, and other conditions. They can analyze the data that they collect to identify the strengths and weaknesses of each steel, and then select the metal that is best suited for their intended use, such as cutting meat or slicing vegetables. For our knives, we use 1050C carbon steel that has a good balance of strength and toughness. As you can see, in most real-world contexts, students have the opportunity to make some decisions about the project. What does it mean to forge? And how do we forge steel? Now it was time for forging, the process of heating the steel to high temperatures around 1500 Fahrenheit to 1600 Fahrenheit, making the steel soft and ready to be shaped. This question of how to forge steel connects with the following standard. Construct an argument with evidence that some changes caused by heating or cooling can be reversed and some cannot. Within this step, students would gain the concept of changes caused by heating and cooling. Construct an argument with evidence showing that heating the steel is a reversible change. The steel can cool and harden again. Observing steel returning to its initial state after cooling teaches them about reversible changes in materials. After heating, students can use a hammer to shape the steel into a desired form of a knife blade. This step involves repeated cycles of heating and hammering. As you can see, students would be learning concepts within a real-world context, which brings authenticity to the learning. The hands-on tasks and the equipment and tools really add to the authenticity. Next, the blade undergoes normalizing, slow cooling to relieve stress, and then hardening, where it is heated again and rapidly cooled in oil to increase its hardness. Students can then take the blade and grind it to the desired thickness and sharpness using tools like the belt grinders. This step gives students the opportunity to test out their knives and give, receive, and apply feedback from their peers and teachers to improve their knives. Once the handle is attached to the blade, it is time for students to polish their knife and present their work to their peers. This is a great opportunity for students to reflect on their learning, the quality of their work, obstacles they encountered, and strategies they used to overcome them. Finally, presenting their learning and work to an audience beyond their classroom. By analyzing how experts solve real-world problems, whether in fields like toolmaking, we see how the skills, knowledge, and processes taught in classrooms mirror those used in professional work. PBL design elements such as inquiry, authenticity, and reflection are not only integral to student learning, but also core to how professionals approach complex tasks. This alignment shows students that what they learn in school has real-world value and allows them to see how the application of content standards, like those in science, prepare them to think critically, collaborate, and innovate in their future endeavors. Thank you so much for watching. Subscribe and hit the like button if you enjoyed the video. Until next time, keep learning in perpetual beta, and I'll see you on the next one. Peace.